Okay, so we started at the heart of the Cartesian plane with a 1 by 1 square. We went over the length of 1 and up 0.7 and plotted a point, and we did that 8 times, up the length of 1 over 0.7 all the way around to create the first 8 points. Then the next 4 points went along the x-axis 1.1, up the y at 1.1, then back here 1.1, and so on. So we plotted 12 points on the base 12 Cartesian plane. Then we connected lines between them, and we discovered that the distance between all those points is the length of 0.5 root 2. We can see that here at this little triangle. 0.5 are the two sides of the right angle, and then 0.5 root 2, that's this triangle right here. And then down here we have a 3, 4, 5 triangle in units of square root of 2, 3 root 0.3, 0.4, 0.5 root 2. And so that mirrors the geometry of the other 8 triangles. So we can see that the entire dodecagon has the length, or in sections, of 0.5 root 2. So the complete perimeter of that dodecagon is 0.5 root 2 times a dozen, which looks like this in base 12. So that gives us a total perimeter of 5 root 2. Then the diameter of the circle that we've drawn using this point here is 0.96 root 2. So that's the distance from 0, 0 to where that line, the 45-degree line, crosses that section of dodecagon. Remember, 6 is half of a dozen, or 0.6 is half of 1 in base 12. So we multiply that by 2. 2 times 0.96 root 2 gives us 1.7 root 2. Again, a base 12 calculation. And that gives us the diameter of this circle. And if you look at the circle, you can see how it's weaving between these points that are on the outside of the circle and these ones here that are on the inside of the circle.